When human AI interaction expands too freely, the user is exposed to more options, more navigation, and more decisions. What begins as assistance can become cognitive load. And when cognitive load accumulates, delivery becomes harder. So the first question was not how to make AI do more. It was about how to shape the interaction so that the work can actually reach completion. From that starting point, 3 evaluation layers gradually emerged. The first layer was the hardware. Hardware defines the physical conditions of the system, how much it costs, how much power it uses, how much noise it produces, how mobile it is, and how much operational burden it creates. The goal was not maximum performance. The goal was the smallest substrate capable of carrying the required function. On top of the hardware sits the model. Its role is to turn available computation into usable capability. So instead of selecting the largest model, we defined capability gates: reasoning, knowledge, tool use, context, and multimodal understanding. The model only qualifies if it can satisfy the objective within the limits of the substrate. On top of the model sits interaction. Its role is to turn capability into delivery with as little human navigation as possible. So we constrained duration, frequency, and the interaction surface itself. At that point, the framework appears complete. Hardware carries the system. The model performs the work, and interaction produces the artifact. But the artifact is not the end. It still has to be consumed. It has to be read, listened to, understood, verified, and acted upon. That final step creates its own burden. So if hardware, models, and interactions are constrained by gates, the artifact should be constrained by gates as well. In the 1950s, radio was already part of everyday life, but most receivers still relied on vacuum tubes. They were larger, consumed more power, generated heat, and remained tied to the home. The invention of the transistor changed that. Smaller, lighter, and far more energy efficient, and made portable radio possible. What had once been a household appliance became a personal companion. For the first time, information could follow the listener rather than waiting at home. But the significance of the portable transistor radio was not only technological. It revealed a remarkably efficient way of consuming information. A small amount of interaction was enough to begin. The listener selected a station, adjusted the volume, and then interaction almost disappeared. What followed was uninterrupted consumption while the listener remained free to continue everyday activities. This architecture matters because it separates the work of accessing information from the act of consuming it. Modern cognitive research helps explain why that separation matters. John Sweller showed that working memory is limited, and that unnecessary operational demands increase cognitive load. Richard Mayer's cognitive theory of multimedia learning proposes separate visual and auditory processing channels. More recently, Shlomi Malumed and Robert Meyer demonstrated that listening and reading do not place the same operational demands on the consumer. Reading requires visual decoding, eye movement, pace regulation, and continuous control of attention. Listening allows information to unfold over time, while leaving the visual channel available for other activities. It does not make comprehension effortless, but for linear informational artifacts, it reduces the effort required to operate the medium while consuming the message. The transistor radio did not only reduce the size of the machine, it changed the conditions under which information could be consumed. This gives us the consumption constraints. Once the artifact is available, consumption should begin through a single interaction, within a few seconds. It should use a medium already familiar to the user. It should not require the user to sit in a dedicated place. It should not require continuous visual attention, and it should not require continuous physical engagement with the interface. The objective is not to maximize the amount of information produced. It is to minimize the human effort required to transform that information into understanding, and, ultimately, into action. The framework is now complete. Hardware constrains the substrate. The model constrains capability. Interaction constrains production. Consumption constrains absorption. Together, these 4 layers define the design space before implementation begins. 2 episodes ago, we introduced a possible use case, a daily audio briefing covering the most significant event that happened exactly 100 years ago on that day. We can now refine it. The briefing should also adapt to the user's current location, so the artifact follows both time and place without requiring the user to search, configure, or navigate. Against the framework, the status is clear. Hardware and model constraints are already satisfied. A switchable local first device has been selected, and a model exists within its capability, memory, and context limits. Interaction and consumption constraints are also defined, but their architectures remain open. This is where the framework ends and engineering begins. The solution has not been assembled yet. The design space has been narrowed. The next episode moves from constraints to architecture, designing the interaction layer and the consumption layer before choosing how the system will be built.